So students, today we start with chapter Semiconductor. In this chapter we have to discuss classification of solids first. Second, the chapter Semiconductor. And in third one part, we have to study about the applications part. So this is the topics we covered. So first we start with topic classification of solids. So students, as we know, classification of solids. So solids may be classified in three broad categories. First one is metal. This is called conductor. Second, insulators. And third one is semiconductor. Okay, so first one by one we come to semiconductor. In conductor, as we know, conductors are those which conduct the electricity. And by insulator are those which do not conduct the electricity. And semiconductor, this is the moderate form. It sometimes behaves like a conductor and sometimes it behaves like a insulator. So sometimes meaning here conductor at 0 degree Kelvin. Semiconductors are treated like a conductor, while above the 0 degree Kelvin it is treated like a insulator. Okay. So on behalf of energy band gap, we have to classify this. So if we talk about the energy band gap, so in order to understand the concept of energy band, we have to first come with valence band. Second, we have to come with conduction band. So in order to understand this, we have to take one example of sodium atom. In sodium atom, if we write the configuration 1s1, 2s2, 2p6, 3s1. Okay. So what we have to see, in first one cell we have one electron. In second one, 1s2. So in first cell we have 2 electrons. In second cell we have 8 electrons. And in third one only 1. So if we draw their configuration, so in first cell we have only 2 electrons. In second one cell we have 8 electrons, 1, 2, 3, 4, 5, 6, 7 and 8. And in outermost only we have 1 electron. So this outermost 1 electron is called here valence electron. And this electron is loosely bound to the nucleus. Okay. So this valence electron is loosely bound to the nucleus because of distance. As distance increase, force of attraction is to be decreased. So this is called valence electron, and corresponding energy level is known as valence energy band. Okay. Now this outermost electron is weakly interact to the nucleus. That is why when some thermal energy is supplied to this electron, it becomes now free. So this electron is called here free electron or conduction electron. Okay. And corresponding energy level, this is known as conduction electron. So what we have to see, for any atom we have valence electron as well as conduction electron, and corresponding energy level is conduction and valence. Okay. On behalf of valence and conduction electron, now we classified conductor, insulator and semiconductors. So we classified on the basis of energy band gap. First we have to come with conductor, second we have to come with insulators, and third we have to come with semiconductor. So in conductor, if we talk about the conductor, so as we know we have two bands, valence band and conduction band. So in case of conductor, it is found that there is a overlapping between conductor and insulators. So because of this overlapping, there is no gap between them. That means whenever there is a zero energy band gap between valence and conduction, so it is treated like a conductor. So electrons which are present in outermost shell is easily free to transfer to move with valence to conduction. Okay. Next we come to insulators. So in insulator there is a finite band gap between valence and conduction. So because of large band gap between valence and conduction, like a barrier, and this is approx 6 electron volt. So because of this large band gap between valence and conduction, valence electron which are free in valence band not easily to move with valence to conduction. So in case of insulator, all the electrons are present in valence and cannot be transferred to conduction. That is why insulator do not conduct the electricity. If we talk about the semiconductors, so in semiconductor there is a finite band gap between valence and conduction. So this the order of band gap is 1 electron volt. So because of this less band gap between valence and conduction, so electrons which are present in valence band initially not come to valence to conduction electron, but if some thermal energy is to be provided to this valence electron, after getting some energy it becomes too free and it moves from valence to conduction. So it conducts the electricity. That is why at 0 Kelvin it is treated like a insulator, and above 0 degree Kelvin it is treated like a conductor. So semiconductor having both the properties insulator as well as conductor, it depends on the temperature. If temperature is to be 0, that means all the electrons are present in valence, then it is treated like a insulator, and above the 0 degree Kelvin it is treated like a conductor. So students, in this chapter we mainly focus on semiconductor. So next we come to semiconductor and their types. So semiconductors is to be classified in two broadly category. Intrinsic, and second one is extrinsic. In intrinsic semiconductor, pure germanium or silicon is in natural form. This is called intrinsic semiconductor. So germanium or silicon is in natural form. This is called intrinsic semiconductor because it is found generally in nature. So its conductivity and resistivity is low. So it cannot be utilized for some constructive purpose. That is why we have to make extrinsic semiconductor. Extrinsic semiconductor means mixing of doping, mixing of elements. So if germanium and silicon is mixed with some elements, then it is said to be extrinsic semiconductor. That means germanium plus some extrinsic element. Similarly for silicon, so mainly germanium and silicon, this is called semiconductor. And for extrinsic, we have to mix with element, and this process is known as doping. Okay, so via doping, extrinsic semiconductor are further classified in two categories. First one is p type and second one is n type. P type and n type. So in p type semiconductor, pure germanium and silicon mix with trivalent impurity. So whenever we mix with trivalent impurity with germanium or silicon atom, then it is said to be p type semiconductor. And in n type semiconductor, germanium or silicon with pentavalent impurities. So when germanium and silicon mix with pentavalent impurities, then it is said to be n type semiconductor. Next we come to how the covalent bond is to be mixed with silicon, germanium with trivalent and pentavalent impurities. So if we classified the n type and p type, so as I have already told, कि germanium or silicon atom mix with pentavalent impurities, and for p type, germanium, silicon mix with trivalent impurities. So we see germanium in outermost shell, this is 4 electrons, and for mixed with pentavalent impurities, so it having 5, 1, 2, 3 and 4, 5. So one covalent bond is to be there, second one is to be there, third one is to be there, and fourth one is to be there. That means fifth one is to be free. Okay, so this fifth one is to be free and it is to be donated somewhere else. That is why such kind of impurity is known as donor impurities, because one electron is to be left and it is to be sent to another one. And if we talk about the number of electrons and holes, so here electron is to be vacant. So electron is said to be majority carriers and holes is said to be minorities. Okay, so when we compare the density of electrons and holes, so number of electrons is more as compared to number of holes. Similarly, if we come to p-type semiconductor, so in p-type semiconductor, germanium, again we have 4 valence electron. This mixed with trivalent impurities. So trivalent means only we have three. So one make with covalent, one with another one of trivalent, second one and third one. So now what we have to see, fourth one is to be free in intrinsic semiconductor. So this fourth one is said to be free electron, or it is said to be acceptor type impurity, because we have to here one more impurity in order to make a covalent bond, and this create vacancies. Vacancy is known as hole. So every time whenever germanium or silicon mix with trivalent atom, so it create a hole. That is why number of holes is more as compared to number of electrons. Second thing, because of vacancy of electron, this is said to be acceptor type impurity. Okay, so this is said to be acceptor type impurity. So this is the classification for N-type and P-type semiconductor, and there are so many applications of N-type and P-type. Thank you.